Our next talk is on the AXIOM open source video camera from Sebastian Pickelhofer.
Perfect.
Excellent. So please give him a warm welcome.
Thanks so much. So what I'm going to do now is take you on a journey into filmmaking, a bit away from coding and all the technical details, into the world of motion picture art, you know, the dream factory of Hollywood. Yeah, that's where we're going to dive into, right? AXIOM, that's a worldwide community, a product, a kind of movement over time. The goal is to create a professional film production tool, right? So we want to actually make films. I want to make films. I never wanted to make a camera, but well, some things led to the other, and that's where we are currently. We have high-end requirements, so it's really about high-end cinematography. And why do we need another camera? I mean, aren't there plenty of options out there already? What you see on the left-hand side, I'm not going to point at the screen, is a camera from the 60s or the 50s, a 35mm analog film camera. And on the right-hand side, you have what's a modern kind of representation of a digital cinema camera, Sony f65. And the paradox situation is that even though the technology itself and the quality and everything, no matter how you look at it, it has evolved. Of course, it increased performance, the image quality and everything. But the paradox situation is that the accessibility and the way you can actually influence the images has quite decreased in contrast to the technology, right? So where the old analog camera was kind of hands-on, it was all mechanical, you could tinker with the motors and everything was like open the box and you have the mechanics inside, easy. What you have on the right-hand side is more like a black box, a computer, no idea what's happening inside, only Sony knows, and you can push the buttons and see what happens, but that's like all you get. So what is the Portos project, what is the AXIOM project really about? And I think there's one quote that summarizes it better than anything I can come up with or anything I could ever say. And it's a quote by Lee Parker, an IMAX cinematographer, and he said, "I grew up as a photographer in the dark room, and I miss the intimacy of watching the image slowly appear on the paper in the red of the safe light. The beauty of an open source camera, to me, is a step back towards the dark room in which making the tools is part of the joy of making the art." So that's why we are here now. So how did it all start? So how did we take the first steps? This is the so-called, shoebox prototype, a proof of concept. Large, cumbersome, strange form factor, a bit of wood inside, very transparent enclosure. And ergonomics wasn't really the focus at the time, but it worked. It actually created a prototype that output images and that we could use and to shoot some sample footage and to actually kind of show the world that it's possible to build a camera like this. And then we took it one step further because we knew that this is something we couldn't do alone. We couldn't do it in a small team. We couldn't do it in our garages. We need to scale it up. So we ran a crowdfunding campaign to build the next generation, the AXIOM Beta, in a way more compact, more modular, easier to produce, so that we can actually give it out to people, that people could build it themselves, we could ship it to them, something that's like available, accessible, and ready for production, basically. And the result of this is the AXIOM Beta developer kit. It's basically the entire electronics, the complete stack of functional hardware inside without any enclosure. So more accessible, you can modify it more easily, no protection for outside filming in harsh conditions, but for development, that's perfect. That developer kit. And this currently retails for around 4,000 euros, so you can actually buy it from us. Sounds like a lot of money, but if you compare it to available high-end industrial cameras or cinema cameras, it's a bargain, right? Yeah. It's all high-end. We looked at image sensors because that's like the heart of every camera, obviously. The plane that transfers light into digital image in the end. And we looked at the market, and there weren't too many options to actually get as a normal person if you're not Sony or Canon. And then we chose the one that was, in terms of quality, in terms of performance, the best we could get. And of course, it's not very cheap. So that also drives the price, obviously. The next iteration, with the prototype being more for the lab and for development, is what we now have here as first time prototype for about 1 or 2 weeks now. The AXIOM Beta Compact. It has a full metal enclosure, all CNC milled. It's a bit heavy. I mean, you can carry it afterwards a bit. It's not as heavy when you hold it in hand, so it's quite ergonomic, but it's a very solid shell, a very robust kind of enclosure, and turns the hardware into an actual camera. It actually looks like a camera already now. Can you take off the camera? We don't know yet how it will retail, how much it will retail. If the electronics are 4,000 already, probably in the range of 5,000 to 6,000 euros, we'll see. And as this is the first prototype, it will still take us, I don't know, half a year or so to actually get this production ready. We still have a lot of evaluation and testing to do, to kind of take it into the field and actually see how it performs in terms of ergonomics and so on. The big picture, or the long-term goal, is something even bigger, where this is kind of reduced the camera to the essential components that you need to actually record images. And the AXIOM Beta Extended, as we have the concept currently, is more like the full-featured everything you could want or need in the future. So that's the long-term goal. It's a concept. It's not a reality yet. But you can see that some elements from the front, they don't look that much different in the concept. So how do you want to control it? Currently, quite easily. I think this is the audience. This will properly appreciate the way it's controlled through a Linux terminal. Yes. Filmmakers, I don't know why, but they're kind of not really into Linux terminal applications and so on. They always look strange when we tell them how to connect and log in and so on. So we came up with a physical device called the AXIOM Remote, which connects to the camera or pretty much anything you want over USB, and which features a small display, a couple of buttons, dials, everything that provides a kind of haptic experience for controlling camera in a sophisticated way. Currently, the way we built the camera, we've shipped around 50 developer kits so far now, is completely by hand. So actually taking every electronics component, putting them on the boards, soldering. It's very cumbersome, unfortunately. It's very labor intensive, but I hope that will improve in the near future with a fully automated industrial process. But our approach is also that we kind of want to keep innovating. And every time a board or the electronics get improved, there's a new iteration, we want to move that into production immediately. So it's definitely not a mass production product. It's definitely not going to be produced in a number of thousands or so. So that is the kind of the challenge for us. How can we always bring the latest innovation, the latest innovations, iterations into the actual production process? Because obviously high prices and low volume, and making it cheaper, but always keeping the innovations concurrent, it's a bit of a challenge. I don't want to bother you with too many technical details, but the heart, the image sensor, it's a 12 megapixel sensor, so we have 4K resolution by 3K in the height, so it's 4:3 aspect ratio for anamorphic shooting, for example. Anamorphic, yes. 12-bit color. It has a global shutter and can do up to over 300 frames per second at full resolution. There's a monochrome version available of the same device, color version, and the near-infrared version as well. And yeah, that's currently the way we actually produce hardware. Some of the boards, I have some stuff here, if you want to take a look later, have over 500 components on them. So yeah. Lots of fun. Who wants to build hardware for us? Maybe that. Yeah, excellent. We'll all bring you into the lab afterwards. And yeah, that's the process of actually assembling the previous prototype with the mechanical parts. And the result is like this, or now with the top handle and the shell and the wooden grip around here added as well in the second generation. Now, beside Hollywood or beside the filmmakers, who would want to use this? Well, there are quite a few people who do high-end imaging, machine vision, scientific imaging, and having a completely open and adaptable, extendable platform available is quite interesting from what I heard. So there's a company, for example, or not a company, it's a university, the Astrophysical Laboratories in Marseille. They used AXIOM Beta to develop their own curved image sensor based on the image sensor we are using currently. There's a company in San Francisco that created a system using 3 of the cameras with said near-infrared sensors to map agricultural land, because plants reflect a lot of infrared light. For development, there's something new as well. They called AXIOM Micro, developed by 2 German students. And they met at CCC, I think, last year or 2 years ago, and said, I want to develop on this, but I can't afford it. So what do? Yes, we build our own camera, of course. And the AXIOM Micro is, in that sense, very much reduced in complexity in terms of cost. It has a small image sensor. It has only 1 piece of hardware attached to the main processing of the shelf board. In contrast, here we have a stack of 5 PCBs. So everything's kind of reduced to the essentials, and that way the bill of materials comes down to around 200 euros only. It's not available for sale, you actually have to build it yourself currently, but all the files are of course available online, open hardware and free software. We are doing Google Summer of Code now for a couple of years, so if you want to join us for this year, please do. The tasks evolve around FPGA development, VHDL, embedded Linux running on the camera, C, C++. So if you're a student, then that would be much appreciated. If you're not a student, no problem. We have plenty of things to do. It's a very diverse community of artists, software developers, filmmakers, cinematographers, hardware, mechanical, optical engineers, everything. So you would be very much welcome and very much appreciated if you want to join us. And this slide reminds me, what would a camera be without actually showing you what it can shoot? So with a bit of luck, I will now manage to move this video, which should load in an instant. Over there. No, it can't. There it is. It has audio, but that you have to imagine. I turn it up very loud from here. Is there actually audio? No worries. Also forgot. It's just music, so.
I got it. Careful. That's the music. Thank you.
And it's gone.
No, but it's going to be on your video. So.
Excellent.
You will suffer for posterity.
So yeah, just look at pictures on this huge cinema screen here. Yeah, well, it's just 2 videos. Yeah, well, why not? 2 minutes long, but it shows the image sensor in all its glory. Yeah, that's it from my side. Many thanks. More details on the website. We will take our babies outside after the talk, and you can actually hold it if you want. I don't know if we move to the tables with the job offers or so, but meet outside at first.
So are there any questions?
Yes.
When will we be able to have FOSDEM, CCC, or DevConf recorded on AXIOM cameras?
Yes, I remember to repeat the question. When will our cameras actually record here? I have good news and bad news. We actually met the people from the video team before and who ran the network and the streams, and they were very interested in using open hardware, open source camera. The bad news is that doesn't alone solve the issue, so we will still have to build a lot of cameras, and they will have to build or buy them or build their own version for lecture recording. Why not? But it's not something that will happen immediately, I'm afraid. But as long as people interested in doing this contribute and push it forward, definitely.
How do you find dealing with sensor manufacturers?
How do we
Require
find?
an NDA or something like that?
Yes, very good question. How do we deal with sensor manufacturers? There are not that many, so indeed it's a difficult choice. All the manufacturers who require an NDA to even get the data sheet, not just preliminary information, but the data sheet, were already left out. The remaining ones, we benchmarked how is the communication, how is the performance, what does the data sheet contain, and that is the result of our choice now.
Can you reveal their names?
The image sensor is made by a company called CMOSIS, which is not in action anymore because it was bought by AMS. So it's now called AMS Image Sensors Belgium, actually. Yes.
How long it takes you to build one of these prototypes?
How long does it take us to build one prototype? The electronics, it's like 5 to 6 boards in the AXIOM Beta developer kit, and we ship one every 5 weeks roughly. So it's not 10 hours a day every day, but still that's the time kind of we need.
Manual focus, manual lenses?
Yes, currently everything's manual. There is a project already where we try to reverse engineer the lens communication, but it's not there yet.
Is HDMI involved in your camera?
Yeah, is HDMI involved in our camera? There is an HDMI output plug-in module at the back indeed.
Do you have a HDMI license?
It's not actually HDMI, it's just a connector that looks very similar to HDMI and somehow works on some screens that also have HDMI, I heard. Yes? Please cut that out at the end. Yes?
What does your image processing pipeline look like? Like your ISP, and then how do you get the data out? Because
Yes.
4K by 3K and 300 frames per second is quite a lot.
How does the image pipeline work or look like? The entire image pipeline or the processing runs in the FPGA in real time. And the advantage we filmmakers kind of have is that we want a very pure and very raw and very unprocessed image. So we actually don't do that much with the image. I can show you the link on the website. In the wiki we have an actual image of the pipeline with all the processing
How do you
blocks.
get it out? How do you get the data out?
Currently over a connector which is at the back and is largely compatible with HDMI devices.
Don't you have SDI output?
Currently an SDI plugin module is in development, dual 6G, but it's not finished yet.
With John Locke and
Yeah, it has 4 connectors and you can kind of dynamically patch them into the FPGA if it should provide sync or timecode or video output input. Yes.
Yeah, last question.
How do you fund currently the progress? I think once there was a European research.
Yes, how do we fund the project? We did the crowdfunding. We got the European Horizon 2020 grant a couple of years ago. And now we're kind of bootstrapping our way up by selling developer kits and by that way, again, affording a bit of prototyping. But currently we have no employees and only the people who actually built the camera in hard labor get any money out of it.
Thank you.
Thanks so much.